Okay, let me start recording. Great. As we dive into this problem, but we definitely want to try to recognize and see where we can make these connections. So I'm going to share my screen and let's like talk through this problem and see where we could possibly draw a connection to some previous problems that we've done. Right. So here we have our ransom note problem. So let's just read it again, even though I know we've already all read it. But given an arbitrary ransom note, oops, string and another string containing letters from all magazines, write a function that will return true if the ransom note can be constructed from the magazine. Otherwise, it will return false. So each letter in the magazine string can only be used once in your ransom note, right? So to visualize this, right, you're thinking you have like this magazine and it's filled with words, or in this case, we could think of it as just like one long string of letters. And we're going to be cutting out those letters and putting them together to make some ransom note. That's essentially the crux of the problem, right? So we look here, if our magazine only had the letter B, not a great magazine. Maybe it's like a picture magazine called B. Anyway, right, and we wanted to have a ransom note that just said A, very threatening. We wouldn't be able to do that, right, because we don't have an A existing in our magazine. Same with example 2 here, our magazine has an A and a B, and we want to say A, because we just saw Happy Days, right? So we can get one A, but then we're left with wanting another A and not having it, because we can only use each letter once, right? And so for example 3, we get this true because we want to say A again, but this time there's 2 A's and there's also 2 A's in the magazine. So that's okay. So this is similar to the sock problem. I would say this is even more similar to the anagram problem. So Maria and whoever else felt the anagram urge, kudos to you. Like I think this problem is essentially identical, right? So in the anagram problem, we looked at 2 strings and we decided we had some rules, right? We said strings must be equal length. That was one rule for our anagrams. These are, I'll say, anagram rules, just to be clear. Right, so we had anagram rules, strings must be equal length, and we also agreed back then that each count of each letter must be identical. Were those the only rules? Do we agree that these were the rules?
There should be lowercase too.
Okay, so we were worried about lowercase. And we'll just say like, were we case insensitive? I don't remember. Yeah, I think we were trying to be case insensitive, right? So case insensitive. So / convert to lowercase. Okay. Did we have any other rules that made things anagrams, or was this it?
No, I think that was it.
That was it. Okay. So for this one, let's think of ransom note rules. So for our ransom note rules, is there any inference we can make about length?
Length doesn't have to be the same.
Length doesn't have to be the same. Okay. Is there a rule we can make about length?
The ransom note can't be longer than the magazine.
I like that, right? Ransom note, that was Brutus, right?
Yes.
Cannot be longer than the magazine, right? Because how can we make a longer note than the magazine? So if the ransom note is longer than the magazine, we don't even need to try. Okay, I like that. Is there a different rule we can construct in regards to counting of letters? Oh, maybe people are writing in the chat. Hang on.
For me, like I have to say that the magazine should include all the letters from our ransom note.
Okay. Yeah, so the magazine is going to have to include all letters of the ransom note. I like that. That's a great start. Um, so we can say uh, each ransom note character must be inside magazine. I like that. Anything else? Any other addendum to that last rule that we can think of? So each ransom note character must be inside the magazine. What else?
Magazine characters can only use once, right? Like they can only use once to construct a ransom note.
So what does that mean for us?
Wouldn't it be like duplicates or something?
So if my magazine is AB and my ransom note is AA, why does this not work?
Because you can't have more than what the magazine gives you.
Exactly. So how can we say that in a nice coding English mix?
The count of like that magazine character can't be that same count in the ransom note?
Yeah. Well, not the same count. So each ransom note character count must be
less
what compared less than or equal to magazine character. Right? So this is all that we really need. And we're going to make this look as much like anagrams as possible. So we'll start off with our first rule. So if ransom, can't spell that word, note.length is greater than our magazine, we can just go ahead and return false, right? Because we know that's not going to work. And so then we can go ahead and create this counter object, right? So which object should I really count? Which of these two do I really need to count of first?
The magazine, right?
Exactly, the magazine, because this is the one that I'm going to be cutting up and decrementing from later on, right? So if I have a count of all the letter occurrences, then I can iterate through ransom note later and check to make sure everything's hunky-dory. So I'm going to make a little helper function because I want to keep this as clean as possible. And I'm just going to call it a counter. And it's going to take in our string. I'm going to have my output. Let's say const output, which is just going to be an object, right? And then I'm just going to make a counter object. Just pretty much the same as the last couple of weeks here. So let character of string, but this time it's with a string, and I'll say output at character. Do we have it? If we do, I'm just going to increment it by 1. Otherwise, I'm going to set the count to 1. Right? And at the very end here, I can just return my output. Now, let's go ahead and run this just to make sure we're getting what we're expecting. So let's say I say let mag counts, and we'll call counter on magazine. And then let's just console log our mag counts. Well, this isn't a very interesting test case. Let's do this one. So we should see that A occurred twice and B occurred once. Okay, so we're like, all right, this is cool. We've successfully written the counter object. Awesome. So now that we have a counter object, right, we have all of our mag counts. Right, this is what we can use for our dictionary. So just like anagrams, we can iterate through our ransom note, and every time we find a character, we can check if our mag counts includes that character. If it doesn't include the character, well, that means we can make the ransom note. If it does include the character, we can decrement that. If we try to key into it and we also get back a 0, right, when we need that letter, that would also mean that we weren't able to make it. So it's going to work actually the same as the anagrams, where we can just go ahead and loop through our ransom note. So we'll say let character of ransom note. I'd like to have a space there. Thank you. Okay, so let character of ransom note. I want to have spaces down here. There we go. Okay, so let character of ransom note, and then we can just do our quick check. So hey, if mag counts has this character, so if it has this character, all we have to do is decrement it by 1 because we're using this character. So we'll say mag counts character minus minus. Else, well, that means either it came back as 0, which is a falsy value, so we'll hit our else statement, or our mag counts doesn't even have that, which in that case, we can go ahead and return our false because we cannot construct this ransom note. If we make it all the way through, what does that mean? What does that mean for us?
It's true.
Yeah, it means we can go ahead and safely return true because we've iterated through the whole thing and we were able to make our note. So let's just run our code and check our work. Okay, that example works. Let's go ahead and submit it, make sure it passes all test cases. And it does. Great. Any questions on this problem? If you'll notice, this is very similar to our anagrams problem. Right, where we had our counts, same type of thing. And then we did our length check originally. We changed some things with lowercase, but then we were saying, you know, we were just iterating through. If it's in there, we're decrementing. Otherwise, we're returning false. And before we were returning true. We added some constraints last time that made us change our code. But the original answer was nearly identical to this. All right, so it's all about pattern recognition. Because if you can remember that one pattern or recognize that one pattern, you can solve a bunch of different problems that all use it, right? So learning a pattern and recognizing a pattern is almost like learning 100 to 1,000 problems, right? Any questions on this one?
Yeah, I guess it's not really a question, but I guess like the tough part for me was like setting the rules, and like I feel like if I like took more time and set the rules, I would have seen like the similarities between that and the anagram problem. So it's like sometimes the wording of the questions like throws me off here and there.
Sure.
Yeah, so like it's just I gotta like take like the situation out of it and just sort of look at what they want me to do, and then I could sort of compare it to a problem I did beforehand, and that's so it's like setting the rule. I got to just get more used to doing that.
Cool. Yeah, that's a great point, right? It's like there is like right. There is more to like there's practicing the problem, but there is practicing trying to get that pattern, and part of that definitely is spending a little time up front trying to like look at it and think, well, what are they really asking? And what other problems have I potentially solved that do this, right? Like if I'm given an array problem, I think, well, is this data sorted? If this is sorted, it's probably some kind of binary search problem. If it's not sorted, I think, would it help me to sort it? That would be n log n, right? If I'm using 2 for loops to keep track of things, sometimes I start thinking, is there a way that I can use an object to fix this? If I have a linked list problem, I'm thinking, can this be made easier with 2 pointers, like a runner and a walker? If I have a tree, is this a binary search? Like, is this a binary search tree problem? Is this a breadth first search? Is this a depth first search? Right? Those are like their own kind of categories. What kind of traversal? Same with graphs. This is going to be more of a depth first search problem or breadth first search problem. And strings and arrays are kind of like the same in that sense. They have kind of the same manipulation type of problems. So it's like, what kind of problem is it? Yeah, that's a good point, Mara. Any other questions, comments, concerns? Okay, then I will stop recording. Let me stop recording.
Corey, what was the last rule of the ransom note?